Hey, good morning, Carl.
Morning, afternoon.
Good
Sorry,
morning.
JB. Good afternoon.
Yeah, for me it's afternoon now.
Hi, everyone. Hi, everyone. Since it is 5 minutes in, I think we should start. Thanks, everyone, for coming. I already sent out the proposed agenda for today. I don't expect that we go through all of the items here, so I think we just start to continue and then proceed as we have time. Last time, we have been talking about the use cases, the index types which contained in the proposal. We went through the first two index types, the primary key index and the containing index, and briefly touched on the IVFPQ, proposed IVFPQ index, but we haven't went into more details around that. So with that, I think we should continue with the IVFPQ one, which is basically a vector index above the currently available array type in Iceberg. And this index could be modeled as kind of materialized view about the quantized versions of these vectors. So basically, the other column data are there, and then the quantized vectors are contained in the index. And this materialized view could be partitioned or put in different partition based on centroids, which are the focus points of these vectors. And here, basically the retrieval part, when we are looking for a value in the index, is like fetch the nearest centroids for our target vector, and then read through the data in those partitions and find the nearest vectors based on the quantized values, and then we can return the values from this search, like the top 10, and after that we can fetch the actual real vectors from the original table and resort the data based on that, and then we can return the 10 nearest vectors for the target vector. Here, the logic or the real knowledge is behind how to define the centroids and how to choose the actual quantizers. And this could be done in the index maintenance part, and the actual choices and the actual method data for these quantizers and then centroids could be stored in Puffin files and could be stored as parameters for the index. And then users could go through them and use that in whatever engine they want to do that. Any questions around that? Okay, then.
So my question is, why do we have to tie the algorithm with index type? So essentially, this is a vector index, but IVF is algorithm, right? You could use other approach. So
Yes.
My question is, as a specs perspective, do we have to tie to algorithms, or we can just say create a vector index? You do whatever way to store those centroids, or whatever way to calculate the centroid.
Harsha?
That's a good question, Inge. So I think it's IVF is, I would say, more of an index type than it is an algorithm to produce an index and an algorithm to search the index. So I feel the index part is a little difficult to separate from the IVF algorithm. But your point about, could there be another algorithm that fundamentally uses the same inverted index?
Yeah.
Yes, there are many, but the inverted index of over a spatially clustered inverted index over the quantized vectors and so on, it's a somewhat fundamental to the vector search land that I think could be best supported as an index type, and which different algorithms and variants could act upon.
Yeah, but I think my point is that the abstraction is you want to create a vector index, and then IVF is one algorithm parameter. So you can have another, it's basically you have algorithm parameter to tune, rather than saying you can only create IVF index.
Let me ask a question if I understand correctly. So what you are proposing is you are proposing that we say that this is a vector index.
Right.
The user decides that this is a vector index, and then there is a subtype for that, which actually defines what is the actual data stored in this index and how it is stored.
Exactly. So it's there are two levels. Like one, you have three index types, like scalar for scalar value, for full text, and then for vector. And each of them have different indexing algorithms. That's my view.
Okay. How I see this, basically, we in the specification level, we need to decide what is the data stored in the storage layer, because it is the only way how we can allow different engines to use the same index type, to know what is actually stored on this, how we can use that. So I think fundamentally in the end layer, we need to say, okay, this is an IVF PQ index where the quantizer is parameters like this. These are the parameters for the quantizers, and these are the centroids for this IVF PQ index. We can add additional levels above that. We can say that there is a vector index type above this level, but for the engines to be able to use this last leaf node, we need to define the contents of this leaf node.
Yeah. So I think the algorithm basically is like a one-to-many mapping. It's not a one-to-one mapping as in this proposal. It's like a vector index. Okay, I have multiple ways to implement this. Maybe you have a default way in this proposal, which is the IVF PQ, right? You can have another way in the future, and an engine can deal with whatever new way they recognize, because under the hood, it's an MV or table, right?
The engine cannot use any other type of vector index until it knows what is in that specific index.
I think they can use their own definition of the algorithm. It's just that it's not portable to other engines. So for example, one engine can say, this is an MV, I create an index with some algorithm foo, and it will result in some MV that the engine recognize, right?
I think the goal in Iceberg is to define a storage layer for tables and views and indexes and UDS, which could be shared between the engines. So
Sure. It's like a.
if it is only an index for a specific engine, that engine could use that define that index as it wants to do that.
Mhm.
The goal here is to define the common storage layer for which different engines could share and use.
Yeah, so I'm fine with that. I'm just saying the IVF PQ seems a default algorithm. So you can say, okay, create a vector index. If you don't say anything, that's IVF PQ, right? But we also reserve extensibility for the future to say, this is a vector index, this is algorithm.
Sasha?
I think we can be, as Peter suggested, I would suggest decoupling two things in the interest of extensibility, right? So there is a quantizer. The PQ part, as you said, is a quantizer. So there are newer quantizers and with different goals, especially for much higher dimensional vectors. So I would say, let's think about, here are the top 3 quantizers the community wants supported, and here are the top 2-3 index types that the community wants supported. And of course, the top one on each, you could say, I mean, it's a matter of opinion, but you could say IVF PQ, like, PQ is the top quantizer and IVF is the most common index type, we could say, and start with that, but leaving open to a few more algorithms and quantizers.
Any other question?
So I think my thought is actually applied to other index types. For full text search, I think today the proposal is turn index, which is word-based. We want to reserve the ability to extend to n-gram based, like it's a parameter on the full text search index.
I guess
Right.
my comment was going to be in line with that, which is kind of like, well, if we're having an index type and then there are subflavors within each of those indexes, do we really need 2 ways to address those? And if you there, we have parallels. If you look at like views, you have view and then you have dialects within those views. So I think the question is there a way to generalize this in such a way that it works across multiple index types and we don't have to define like very specific things for each index type? There's kind of a broad category of this is a type of index, and then this is the specific implementation of that. I don't know if we expect to see that there's going to be huge varieties of these. Like the more you add, getting back to Peter's point, it's like the less portable that becomes, right? If you have 6 different flavors of or 6 different algorithms for a specific index type, who's going to implement all 6, right? So is there just one that we want to define? Do we want to leave it extensible? Do we think that creates more confusion because we'll just have a proliferation and it never actually becomes standardized?
Yeah, second Dan's point here. So I would rather define a few types of indexes well, which could be reused cross engines, than and I still would like to keep open the possibility for the users to create their own indexes, and after they found it useful, they could share with the community and come back to us and, okay, guys, look, this is the new term index, which is way better than your current one. You should store these more data there, or store the data differently. And when we see that, okay, there is a merit behind that, it would be nice to add the specification, then we can add the new type of index. But I would try to focus on a very few shareable index types.
Okay, so I mean, that sounds very similar to parallels we have. Like the file type is a good example where we explicitly allow certain file types that we support. And if you want to add more, you need to convince the community that like all the, I's are dotted and T's are crossed in terms of like interoperability and have we thought things out appropriately. But it does sound like we're talking about index type and then something to distinguish within that index type how it is different from others, whether it's algorithm or, because that may, like algorithm may not be the same thing across all of the index types. So we need something that kind of like defines that subtype.
Okay, so
Yeah, I
basically,
think type and the subtype makes sense.
okay, so basically type and then subtype, and subtype defines what is actually behind that.
Mm-hmm.
Okay, cool.
But we can figure out what a good name is for that subtype. Is it like, implementation? But there is a second layer to that, I think, is what everyone's saying.
Okay, if you have good ideas for namings, don't keep for yourself. I'm happy to incorporate that. I'm not good at that, but I will try to come up with that one. Okay, any questions around the IVF stuff? Then I would ask Harsha or Suhash. I'm not sure which one of you would like to talk a little bit about the DSKN indexes, which is way different type of indexes than the previously discussed one. This is also a type of vector index. Who start? Harsha?
Yeah, I can introduce a little bit. So DSKN is a graph structured vector index. Ingi brought up IVF, which is more like a spatial clustering based index. This is slightly different in that every vector gets its own graph node and so on. The advantages of this kind of index are that it's much more scalable. Like as you go to 10 million, 100 million, like really big data sets, the asymptotic, the query the query complexity asymptotics diverge quite a lot. So this graph indices become much order of magnitude more efficient at very large scales. And we have an implementation. Before we get into the implementation, the other good interesting property of these graph-based vector indices is that they're highly updatable, right? You can actually just tail the operation log of a database, keep fully incrementally updating this index and never have to rebuild it for quality, right? And we have indices running for months in a very high throughput stream and so on. Further, these is also amenable to many more complex kinds of indexing, right? So we have indices defined just not on vectors, but on vectors and plus attributes. So you can do pretty fancy indexing extensions of, DSKN and so on. And all of this technology is already operational in many companies and so on. And there is a implementation of DSKN on GitHub, which is very modular. And it's designed so that you can put it in any database, any memory tier, and it's very flexible. And in fact, most of the it is integrated with at least 7 different data stacks that I know of. Anyway, so that's the implementation side of things. And just like we might have IVF index, I think it makes sense to also have a graph structured index, and for which we propose DSKN because of its adaptability to various databases, memory tiers, and also extensions to various different indexing needs, including streaming and composite indices and so on. So I'll pause there.
Okay, so what is very important about this DSKN index, it has somewhat different requirement list than the materials based kind of indexes. Many of this data is stored in binary blobs, most probably we could model those using puffin files. And based on these puffin files, we need to create different versions of the Discanian index for a different status of the snapshot of the tables. So if the user queries a specific table snapshot, it could read the correct version of the Discanian index. You can check out the document Harsha and Su has shared those on the mailing list as well. So if
Can
you
we-
don't, okay.
Can we get those linked in the doc as well? Like anything that we can like link to for any of the example implementations, it's helpful to have it close together.
Yeah, I will definitely do that.
Yeah, because I haven't seen that one yet. You know, the typical questions are things like the reader-writer requirements, the questions about like how do you associate like the puffin files in the bind?
You probably lost Dan. Okay, so everybody's here, just Dan is dropped. Dan is.
Yeah, it seems to be stuck. Yeah, indeed.
Okay. Let me ping him. Okay. So
from my side, are we saying we're talking about two different inverted index algorithm here, or is one? As a concrete example.
so IVF is one vector index, and Discanian is an absolutely different one.
Okay, two. We're talking about two. Okay.
Yeah, so the IVF index is more similar to the materialized views kind of stuff. You still need UDFs, you still need the centroids for partitioning there, but then you are querying like a table, using it like a table, reading a partition and then reading data from there and finding then scanning the data and finding the vectors nearest for your one, the searched one. But the Discanian is absolutely different. You have a graph algorithm to find out the nearest node for your vector.
But it's still stored as a separate kind of storage table, is it? It's just a different way of cluster data, different way. I don't know if it's a partition for the graph algorithm or not. Maybe not.
It's I mean, in addition to the quantized vectors, in which it shares with IVF, PQ, and so on, it will also not materialize, but you need a graph, you know, where the nodes are the vectors themselves. So you need this additional column or table to run this index type, and you need to keep, you know, updating that as the data goes along, as you ingest data.
Do you want to go to detail on the read-write requirement, a little bit detail, or I think that's what Dan was asking before.
Yeah, I think another perspective is about how do we store them, like the storage layer. Are we use one puffin file or multiple puffin file? How do we mapping that with manifest file as well as data files?
So basically, the data itself is could be stored in multiple ways. Part of the graph itself could be stored as a Harsha, is it columnar-oriented, the graph itself? In column-oriented files, the graph is stored in column-oriented files, or it is also a binary blob?
I'm happy to go either way. Let's start with column.
Okay, so it is at this point not decided yet. The proposal is open in a sense. We propose first start with the columnar oriented stuff, but if we decide during the definition of the DSKN index, discussion of the DSKN index, then we can move forward. So it could move in either way based on the decision of the community. In the beginning, in this stage, I don't want to go into this low-level part of the specific indexes. First, I would like to get the metadata level right, and then when we have the metadata there, we can go to the specific index types and define the requirements for the specific index types there. Here, what I would like to do is just go through the high-level requirements so we understand what are the requirements for the metadata. So what then asked makes perfect sense is what the DSKN requires from the writers. We don't, DSKN index, like most of the vector indexes, doesn't really good for immediate indexing of the data. It is an asynchronous stuff. You add the data and the index part later during index maintenance process. So no requirements from the writer side, and the reader typically does, if I understood Harsha's description correctly, what the reader typically does is search for the index, and then it knows the version of the index, and after that it might need to do a brute force search for the data arriving after that, or it could the index could have a quick, not compressed data part which contains the fresh data, and this is like almost again like a brute force search for this new incoming data. Okay.
Do we allow multiple versions of all the same snapshot?
Pardon?
Do we allow multiple version of index for the one snapshot?
Okay. So the question is whether we have multiple index version for the same table snapshot. This is so that was the question. So if we have one version of the table, could it have two index snapshot version for the same table snapshot? Harsha, do you know anything about that?
I mean, there's nothing technically stopping from having that. I think I would say that's more for the I think, Peter, maybe you have a better taste in whether that should be allowed or not. From an indexing type perspective, I don't see why you cannot publish both an IVF index and a DSKN index at the same time. In fact, they can jointly use this quantizer of these compression functions. They can jointly use a compressed representation table, but you could have a clustering IVF and a graph DSKN based indices side by side, and maybe different engines would prefer to consume one or the other. So I don't see a reason not to exclude it.
Okay, so basically, different index types or different index subtypes, you definitely could create for the same table snapshot parallelly. What a little bit more questionable is whether you want to have two index snapshots for the same index time, the same subtype for the same table snapshot. I don't really see a value there. Most probably one of the indexes is more recent, one of the indexes is better, and you don't really would like to use the other one at this point.
Yeah, and this is my question. Yeah, I think Peter get it right. So my question is more about for the same type of like the IVF. If we have for one particular snapshot, I will allow multiple versions exist. One of the constraints, if one version did not do a good job, then it's basically immutable, or you don't update them, you create a new version on top of that to replace the existing one. So that's usually what Iceberg does for the all these metadata or table level. We don't make it updatable, we just make that immutable for one particular version, then throw it away when we have a new versions. That's my concern. If one asynchronous process does not doing a good job, or some implementation did not doing well for one version, we can actually replace them with the new one.
Okay, so that's actually a good point. So if we had one snapshot for one index snapshot for a table snapshot, and we would like to update the index snapshot for the given table snapshot, we probably need to have kind of history-like stuff, because some older readers might still read the old index snapshot, even though we would like to update that. That's your point. Yingling?
So my question to Harsha is, can the disk ANN index be expressed as an MV? Or it has to have some very special way?
Sorry, I didn't get MV, you said?
Yeah, so basically the index
Materialized view,
Yes.
oh, sorry, you mean. It is not a strict materialized view because it computes a completely different data structure, i.e. a graph, right? So so okay, let me maybe get into some detail at the risk of being redundant here. So you have the vectors, you have a snapshot of the vectors, and you generate another table or column that has these compressed vectors, and we can have opinions on how to compress it. There are a few different compression functions, so that should be part of the index. And having compressed these, you go create yet another column where each row corresponds to one vector, right? So there's a one-to-one corresponds between the vector, the compressed vector, and the graph column, and each row corresponds to one vector, and each row points to other rows in this
I see.
column, right? It's a graph, right, where each graph is a vector. So in that sense, it's not a different materialization of data that already exists. It's a completely different nature kind of data, right?
Yeah.
One and two, index. It's an index, so you have to keep it updated, right? I mean, the intent is that, as Yufei was pointing out, these things go out of sync, and we've done a lot of work on how to incrementally update this index. We've written, I can share with you some research papers and also implementations on how to efficiently update this index. So when I say disk ANN, it means all of this sort of technology and ideas put together.
Can I just touch on the question about like materialized view, because I do think we need to be careful about what are we expecting when we say, like represented as a materialized view, because materialized views are handled very differently across different engines and have different capability. And so like, as we talked through a couple of these index types, you can imagine that like, yeah, you can have a representation that is effectively a table, right? So that would underpin a materialized view. But saying materialized view also might imply that, hey, there's some sort of reconciliation that's happening in the event that like the storage is not up to date. And I'm not sure that we can necessarily rely on some of those behaviors with indexes in order to provide accurate and up-to-date information. So I think we do need to, at some point, like as we enumerate like the different index types, like are we saying, hey, like a primary key kind of index, we can store that as a table, and this is what it means to be out of date. If we want to use something like a materialized view, is that just a mechanism for the people refreshing the index to actually produce data? Because that would be closer to what we've discussed as materialized view for Iceberg. Or is it a binary representation where we need some sort of structure and referencing from Puffin files? And what does that, reference look like? So I think the actual materialization of the actual index is a little unclear to me at this point. And we have a number of these options, and some of them may overlap with different index types. But I'm actually very concerned that like we think materialized view might be a solution for these without understanding fully like what are we supporting from a materialized view, what kind of behaviors are we expecting? So
yeah, I totally agree with Daniel. That's my initial reaction on the proposal. Basically, I think materialized view have more strict requirement on the storage than indexes. If it's just the index, you have lots of flexibilities for the storage.
And if you look at like what we've discussed for the materialized view spec, where we stand today is like we're largely where like Postgres is, which is a very basic like you materialize a view, and then that storage, like it never is not fresh, right? It is always available to be consumed, and the only thing that you can do is like refresh that state. There's ways to check state and various other things, but unless we build in a lot of constructs within the index definition on how you behave with that, which would then be further like refinement of what the materialized view spec is, you may get inconsistent implementation. So we just need to be a little bit careful about what we're saying for materialized views.
Yeah, and also I think a materialized view also has different privileges from the base table.
Well, those
are things that we need to be careful so that engine doesn't create breaking changes. If some engine doesn't allow you to directly query the index, but that's we can discuss that later.
Stephen.
Yeah, I want to follow up on what Yufei was saying earlier. I think for, let's say, for one particular algorithm, there should be only one index snapshot at the latest. There could be multiple snapshots mapped to the source table or the base table snapshot. For example, you can do an incremental index maintenance, then you do a major compaction somehow that just update the index table with a new snapshot. But in the end, the latest one is the one you should use. So yeah, I think we probably should not prevent to have multiple index snapshot. We manage to one table snapshot. But
Stephen, would you think that that means that like technically you can use any version of the index, and it's just a matter of like how much is not covered by the index when you use it? Because like you can, if you think in terms of like snapshot lineage, you could say, hey, I've got one that's current for the snapshot I'm consuming that's clearly covered, and it should cover the entire table. If it was the prior one, then anything that was added in the new snapshot is not covered by this index, and I have to handle that separately, but I can use that index for anything prior. But doesn't that extend to any version at that point? Like you could say, hey, I can use a version that's 10 versions old. I just need to handle everything that's incremental in the latest 10 versions outside of that index.
well, I think for the consumer, they probably should just use the latest index snapshot.
Yeah, I agree. Like they should use it, but like, extending from that, like, wouldn't that mean that any index is consumable? It's just how much do you get covered by the index versus how much is not covered by the index?
Yeah, if not covered, you need to do the brute force search that Peter was mentioned earlier. That's it's definitely viable, but I think probably most consumers they should just use the latest index version plus the whatever remaining delta.
Yeah. But then like extending from that, that means that, hey, if you've got multiple indexes or anything, like all you're doing is you're looking back to find the latest, index that has the type that you're looking for or the behaviors that you're looking for. And then you just need to handle what isn't covered by that index.
Yeah.
Is that kind of from the reader side, is that really practical for the index querying? If that's so, that's awesome. Means you don't have to put a lot of the writer side requirements, because if you like strictly enforce that, every time you write the index for one snapshot, you have to make sure they're complete. It's a kind of a very strict requirement, so that writer have to do that.
I think in each of these cases, we have that question of like, one, how do you determine what's covered and what's not covered, right? And then like, if the cost of calculating that is too expensive, like, do you get benefit out of the index, right? If I have to do an incremental scan for 10 versions, do some sort of diff and compare to just like figure out what changed, and then compare that against some sort of index that, is large because it covers most of the table, like that needs to be taken into consideration, because then like that almost makes it a writer requirement at that point. Like if being off by one is so expensive because of the calculation and you lose all benefit, then you effectively need to have a synchronous update.
So basically, that's what the proposal tries to handle in a way that it says that the index table snapshot would be so the table so index query. The index catalog query should return what are the available index type and what are the available table snapshot IDs which are covered with these indexes. So after that, based on the index type and the available snapshots and the snapshot queried by the user, the engine could decide whether it wants to use that given index and query the other details around it, or it just gives up and says that this index is not something which is usable for me.
So I think this also comes down to the granularity, because we see, okay, the file level index potentially quite useful. It's a finer granularity that we can use, because if you don't have the index for this file, we can skip that. Then manifest level also very handy, because you can actually have one group of a data file that has been, say, okay, all of them has been indexed. And another complication may come from the delete, because we have a delete applied to certain data files. Then how do we get out of that, remove that index as well in that case? That's some complication we may have to think about.
I think again, it's something which should be done by the table maintenance or the writer. In this case, since we don't want to, at least I personally really against defining any writer requirements, because that's really makes very limited use cases for our indexes, because the writers are. So then there won't be any writers who are able to update these tables. So that's why I think it should be the table maintenance who takes care of that. And there are several techniques with the primary keys. And we discussed it with Stephen, that like we could create deletes for the indexes as well, or whatnot. But again, this is something I think which we could push behind below the index maintenance, and index maintenance should decide how to store the data and how to make it available, and what is the layout of that. Sorry, Stephen.
Yeah, I think for deleted rows, if the reader always validate the index result with source files, it can check, okay, if this row still exists, then means I can return the row. But if it does not exist from the source file, that means the index can have a little bit stale information, and you should just ignore the index result, because this part of the index, because the data removed from the source data file, if the reader do the additional validation. Yeah.
Yingyu?
Yeah, I think what Yufei and Steven said is exactly why tying index with materialized view might not be a good abstraction, because materialized view has certain requirement on handle deletes, where for index you can hold the deletes for a long time if you do what Steven said.
So
right?
yeah,
so like for index, my point is that index has much flexible for storage than MVs.
But then you define very, very strong requirements for the readers. I think if we just state that materialized view is something which we provide, then it's very easy for the engines to start using the first few type of indexes. And then we can move forward with the specific ones which are better suited for specific use cases.
So yeah, Peter, I think in your document, you also mentioned about included columns. Basically, you want to piggyback some column into the index data so that when you return the result, you don't have to go to source table or source file to retrieve those columns, right?
Yeah, there's actually like two different, very distinctly different paths of like producing data from indexes. One is that the index actually contains the data in which you're reading and you're producing from that. The other one is that you're doing effectively a planning operation on the index, right? And you're getting which files you need to consume back.
Okay.
And like getting the files to consume back introduces some problems, because those files, like if you have a delayed index, if it's out of date, you need to know that those files are still in the table metadata, right? So you may still need to do a scan and join to make sure that like, hey, you're not referencing old data.
Coming from the table snapshot. So if you have a table snapshot which contains those files, then these should be part of the table metadata. So it shouldn't be that big an issue.
Oh, hopefully. Like, I mean, you still need to go and figure out, you have to do that comparison, right? That I got this set of files from the index, and I need to compare against the deleted files from the metadata. And you're effectively like combining a CDC operation on top of a scan operation against the
CDC is an issue. Still, the original stuff is that you are coming from this table snapshot. You are fetching the index for that. You see that this index is for that other table snapshot. You know that at that time, the data files which return by this index should be part of the table data, but you need to have the CDC above that. That's correct.
And you almost have to do this membership check if your index is not up to date.
Yeah, I think
And
because
if we have an index where you're actually storing the values in another table, then you also need to potentially store where they came from so you can do that check, right? Because how would you know if I've got a materialized table of like a primary key index? How do I know which rows came from where? So I should be able to include or exclude them. So there's different challenges for both.
That's why you need these materialized view indexes. That's why they contain the file name, the position, and based on that, the engine could do their work. And then the change set could be applied again based on the change set arrived in the meantime. Do we want
I think the problem is that the materialized view is more strict. For example, you cannot store duplicates in the materialized view, but you can actually store some duplicates in the index because you have reconciliation and membership check steps at the end.
Okay. So do we want to accept these stuff?
We don't in Iceberg. Reconciliation is not a thing in the Iceberg materialized view. So again, like that again is hey, we're associating a behavior of certain materialized views to how we want to use it. So you can't actually do that. The storage table has to have distinct values. It can't have a reconciliation query.
Sorry, guys. Basically, if you are using the materialized views, they are usable for indexes. There are better indexes with different physical representation, which are easier to maintain, but not easier to consume or engines at this point. If we are starting to define our index types with the smaller, lesser requirements than the materialized views, then we might be able to provide something which will be better in the future for our consumers, but it will push way bigger work on them in the beginning. If we say that these first type of indexes are materialized views and they are able to consume that easily, every engine could consume that easily, even we can do it some cases during the planning phase, then we gain a big step and we will keep open the door for the future stuff as well.
So I want to revisit this discussion of materialized views again, because I don't think it actually has overlap based on the way that we've defined materialized views in Iceberg so far. It doesn't seem to have a material overlap with how we think about using storage for indexes. Why is that? Because it is purely a materialized representation, which means that you might as well just use a table, right? You're not getting any value out of having the SQL text because there is no like reconciliation query in the definition today. There's nothing other than the physical data that can be consumed by somebody else. The only way that a materialized view would be valuable is if the SQL text is the thing that is constructing the data for the actual index. And that's only beneficial to whoever is actually then doing the refresh of the materialized view. So it's actually like the idea of materialized view makes a lot of sense in other contexts. And the way that we've defined materialized view, I don't think that there's actually a ton of overlap. And you're probably better off just saying, hey, we're going to store it as an Iceberg table in this representation.
Okay, but if it stores in Iceberg table, you need to define the way how to maintain these indexes.
Yep, absolutely.
But it is exactly the same as the way to maintain the materialized view.
Well, not so when you say that though, like all you're saying is like, hey, there is some logic that constructs the result that goes into that storage table, right? If you can represent that fully as a SQL statement, then yes, you're right. It would be equivalent to a materialized view because reading from that SQL statement and writing it into the storage table produces the data for the index. If that's
And
true,
this is what I did with the indexes.
okay. If that's true, if there's anything that's more complicated or it needs to produce a binary format or something like that, like then it can't really be represented that way.
So Peter, which kind of index can be explored using a SQL?
Primary key index,
Yeah.
the containing index, and even the IVFPQ index.
But it also potentially needs
If you calculate the centroids previously, because you don't recalculate the centroids every time, you recalculate it very rarely. Then after the centroids are available, then putting the actual values in the IVFPQ index is just a materialized view.
Okay. So I think there are some specific things in terms of like what you need to store in the materialized view that get kind of hairy because like, hey, even the file path, like producing the file path, like the actual schema that you need for the materialized view, like many different flavors of that. I'm not sure that it's available in all engines to say like, hey, where's the file path? Or I mean, the row position you can probably get through the SQL query. So I think that it absolutely can be done. I don't think that a materialized view is necessarily a requirement. So I think the question is just like, define what the storage schema is. Like, hey, what are we actually storing in the index? If we can represent that with a materialized view and you can refresh it by calling refresh against that, that's fine. But consumers don't care. Consumers only care about what the storage table is and the schema of that storage table.
Okay, exactly the things which are defined by materialized view.
Mm-hmm. And you know, I also kind of question, like, do we want to tie this functionality to materialized views? Because that makes it that much harder for people to implement. They have to support materialized views in order to get indexes.
And also, material view won't cover all the index requirements. A graph node, it won't be stored as a material view.
Yeah, but some of the main ones, like primary key index, you know, like, so if I'm implementing, like, I have to first implement materialized views in order to get a primary key index.
My feeling is that we are reinventing the materialized views for most of, or for the first 2 or 3 type of indexes, and we can just copy and paste the stuff from the materialized views requirements.
If it's really that close, then maybe we should consider using materialized views. I think we should just explore that. Like, I'm open either way. I do think that, like, that adds an extra level of complexity, especially for consumers. Like, hey, you know, now I have to go through this materialized view indirection in order to get to the storage table that has my index.
The users don't have to go through the materialized
the engine
stuff.
The engine, any consuming engine
don't have to do that. Only the main index maintainer needs to somehow maintain the stuff, and this is maintains the same way as a materialized view.
But if you have to read from the materialized view,
you have
to
read from the table. The materialized view is a table.
It has a table, but you get to that table through loading the materialized view and looking for the storage.
I understand your point now.
Yeah.
So you are. So I'm using the materialized view because this is a very, very similar mental model. How it looks like. It doesn't have to actually be a materialized view. Really.
Exactly.
Oh, sorry. I get this whole misunderstanding. It doesn't have to be a materialized view. It is just a similar construct that like the materialized view. Okay. I will take a look at the document and I will try to
exactly. So Peter, even for the primary key index, you know, not using materialized view also offers you quite a bit of flexibility on what's stored in the index. For example, you can,
ask question in this case, because she's working on in the last few weeks she was working on the primary key index stuff. So I think probably she has more context on this part of stuff.
I think we're on the same page. I think Peter earlier mentioned both just a conceptual model is the same as the material view. It doesn't mean literally we have to use material view. I think we're on the same page. Yeah.
Exactly.
Okay. Okay, we only have left 4 minutes. Huashin, anything which you sorry for taking up the whole meeting.
So, one topic I want to bring up, I think if people do you want to talk about the story, the reference, the index reference from the table, or we want to just load the index entity from the catalog? Do you want to talk about that? That 4 or 5 minutes probably is good to get.
Yeah, I think we can talk about. So we looks like we have certain consensus that materialized view will be a separate entity within the catalogs, right? I think Dan, Jamie, and then Peter, we have a lot of discussion on that, which I think is the right direction. But in terms of how do we refer from the table, do we have any
Did you mean index or did you mean materialized view? 'Cause you said
index? Sorry, index.
Yeah.
Index. So that means like within the catalogs, we have a separate entity for the index close to the view UDF, right? So we have one table as the base, and we have potential of 5 different index for that particular table. How do we refer from the table, right? How do we connect them? Right. One of the ideas is we still can put one camera reference within that table. In that case, every time you go to that table, you know that entity. Pretty much what we did, I think, what we did for the UDF. You don't need to actually put any files or any like metadata file paths. We don't have to do that. What we do is we can just put the identifier of that index. Then every time you go to that, you go to the same catalogs and to grab this index, and then you have that's always go to the latest one potentially, or depends on how these engine to read and update them. So you just go to that one, find from index, found that particular index from the catalogs, and load the metadata files, and then to read and write on top of that.
So the catalog provides us a lot of flexibility to do a number of different things. And like, if we're talking about table specific indexes, of course, we can always have like a /indexes endpoint or something like that to get the list of indexes for a particular table. But we can also potentially return that set of things, at least enough information so that you don't have to go back to the catalog in a load table request. Like you could actually have a structure in the load table that's a companion to the actual table metadata that would be index metadata, so you don't have to do 2 hops. Then I think, Stephen, like back to the discussion of like the multi-load endpoint or bulk load endpoint, that's generalizable as well, so that you can say, hey, I'm looking for this identifier. Go get me all the information as a client that I need for this. And that could include like the table metadata if it's a table, and the index information. So I think the question is just like, do we want to like duplicate this functionality in many different ways, or do we want to start transitioning to just like a bulk load endpoint where the catalog can return all relevant information to circumvent some of this like multiple hops back and forth to the catalog? Like I load a table, it says it may have indexes. I have to go hit indexes endpoint. I have to load the information for those indexes. That's a lot of round trips. So I think the question is like, do we lean all the way into a bulk load, or do we provide separate endpoints for everything, or do we do something in the middle? Yifei?
Yeah, I think bulk load is fine. Like I think I'm talking a little bit different topic here, because we have another option when we talk about, we have table/index, which make the index a complete new type of identifier, makes the identifier resolution much harder, because right now we cannot really rely on the leaf nodes, which is always to be the table, view, and a UDF. And if we do table/index with another identifier concatenates after the table, then this particular identifier will be a very special identifier. And when it comes to any resolution, then it becomes complicated, because you have to, other than the identifier itself, you have to understand identifier types. Then this is become complex, especially like another complication is when you have a nest namespace, you don't really know like what's inside this identifier. So other than we have slash index, which added new type of identifier, we can actually put the reference under the table, right? And in that case, you can still, if you want to do the block load, load multiple stuff, you can still, every time you load table, kind of know what's reference, what's all these index referenced by this table, and it's load them as a patch.
I think we're out of time. It would be good to see this kind of sketched out in terms of like, what are we talking about? I'm not sure that I'm actually fully following what you're saying for the endpoints, because I would think that like all the indexes would be scoped to a table unless we have cross table indexes, which I haven't really heard anything about. Then we would, yeah. Yeah. So like I think maybe getting a quick sketch of like, hey, what do we think those endpoints might look like, and why we think that the other approach may not be sufficient would be helpful.
Let's continue this kind next time then.
Yeah. Thank you very much. And sorry, Huashim, for taking all of the time. See you next time.
All right, bye.
Bye.